Okay, today we're going to do ROBO 122 Lab 4 Filter Regulator Lubricator Inspection. We will investigate the construction of filters, regulators, and lubricators. When we're done, you'll be able to look at something and determine whether it's a filter, regulator, or a lubricator. I will take apart and reassemble each of these components. I'll describe how it works, what's inside, where the air flows and all of that. We'll explain the operation of them. You will be able to do that, and that's what the goal of today's lab is. Today, I'm Richard Day. I'm here to take apart a filter, a regulator, and a lubricator, the three units of the air preparation unit. This is a filter. It's brand new to me. We just came in here today, so I'm the first one to take this apart, and we get to see how it works. They conveniently give us an arrow to show direction of airflow. Air comes in this side, comes out that side, and we're going to look at what happens inside while it's going from one side to the other side. Okay, when we take the bowl off, we can see what's inside. If I look in here, the air comes in here, and it can't get to my outlet unless it goes through the bowl. This is the outlet. As you see, my finger in there, the outlet goes straight out through here. So for the air to get from this side to this side, it has to pass through here. So let's look over here at the bowl. Here's in the bowl, we have the filter element. If I just get my finger in the right place, it just slides right out of here. We'll look more at the bowl in a few minutes, but right now we're going to look at this piece here. When the air comes in, you see all these little veins here. It will get the air, will come down, and passing through these veins will get it spinning around and around inside the bowl. This fits fairly close there, but when the air is spinning around, larger particles and droplets will adhere to the side of the bowl or impinge on the side of the bowl and roll down to the bottom. So liquid will build up in here. We have, as I take this out, this piece here is kind of a baffle. It's so that the air up here is swirling around. We don't want the air down below the baffle to be swirling around. It would pick the liquids up again, re-entrain them in the air. So we keep a dead air zone at the bottom of the bowl so that the liquids can slowly rise. Here in the bowl, this big black thing, if I turn up and down, you can see it floats up and down. It is a float for an automatic drain. If we have a lot of water in our line, the water will build up here fairly quickly, and we could manually drain it by turning and opening this drain down here. But with the automatic drain, we don't have to come around as often to check it. As the water comes up, it lifts the float up, opens a valve to allow the water to drain out, and it will come out pretty fast because it will be pushed out by the air pressure in the filter. This bowl, transparent bowl, is made of polycarbonate. It's a very strong material. It's used for bulletproof glass and that kind of thing. So it will withstand the pressure in the bowl quite easily. It can be damaged by certain solvents in the air or mechanical damage, so there are alternative bowls. This is an alternative bowl. This is metal. It has, because it's completely opaque, it has a sight gauge in here so that we can see if water comes in, it will come up, and there is a mark for maximum height of the water. But again, this one has an automatic drain in it, so the water should never get up that high. If it's got that high, something has gone wrong with it. So our air was, back when we were looking at this element, was spinning around in here, and it wants to go out through the center. It has to go through this element here. Now this element, I'm not sure what the material is because I haven't. But it's a depth element of some type. All the air has to pass through here. There's winding passages between all the small particles that make this up, and the air Sometimes particles will get stuck in gaps between two small particles. Sometimes they are turning a corner to get around a particle, find another path, will cause the air to, particles in the air to, by momentum, hit the sides and stick there. These elements are not reusable or cleanable. You have to replace it when it gets too dirty. We're looking at the vanes again with this all separated. We can see how they're just on an angle just to cause the air to start spinning around. And that's pretty much all we have to show for this. The element, when you replace the element, you drop it in there, you put the baffle back on the bottom, put it down tight so that there's no path for the air to get around it. And then we snap that back on there again. And we're back together, ready to go again. And that is our filter element, the first element in the FRL filter regulator lubricator. This is a pressure regulator. That's the second unit of our FRL that regulates the pressure. We have an adjustment here. We can, if we turn down more and more and more, the pressure will be increased. We'll see what's inside to do that when we get it apart. We can release it off here. This one has a lock. If I get it to where I want it to, I can close it down, and you see there's a hole in the top here. I could put a padlock on there, or just a screw or something, a pin or something, to keep this from being able to be adjusted once you get it locked in place. This regulator has a pressure gauge built into it, which is handy. Many regulators just have a tapped hole where you can thread a pressure gauge in, but the same thing, you have to have a pressure gauge at a regulator, because how else would you know what the pressure is set to? Okay, so now we're going to see what's inside this. We have to take it apart. I'll try to get the cover off here. I did it before, so I know I can do it. There's the little lock there, a little lock there. Ready to slide that off. And now I will leave the pressure gauge on. It doesn't have anything inside that we need. We'll get our little handy tool here and loosen that up. We'll take the bottom off. And set some parts out. And now we'll take the top off. And this is the piece that makes it work. This is the diaphragm. Without the diaphragm, we're not going to get much pressure regulation. So let's look inside here again. We have, as usual, a directional arrow showing that the airflow is going that way. So the air comes in here. So I put my pointer in here. You see the air again comes into the outside area to get into the system. It has to go out through the center here. We have our little poppet here that will sit in there, and it moves up and down with the diaphragm. So as this pushes down, the diaphragm pushes down on it, it opens it up to allow the air to pass out through the opening here. We have, here is a seat, here is a rubber sealing surface, so that will seal tightly when it's pushed up, when we have enough pressure downstream. Taking it out, there's a light spring underneath here that just makes sure that the poppet will follow the diaphragm as it moves up and down. Okay, so I keep saying the diaphragm moves up and down. What makes the diaphragm move up and down? Well, on the outlet side here, we can hopefully, if the light is right, we can see that there's just a little, it's hard for me to see it, you see a little tip down there? It comes up through this little opening right here. So the air pressure on the downstream side is going to act on the bottom of the diaphragm, which will make a force pushing upwards. See, this can move up and down quite a bit. So on top, we have this big spring. This big spring is, yeah, I'm not going to be able to compress it. So the big spring is pushing down on there all the time. Air pressure coming below moves it up again. So you saw we don't have very much travel that this can go. So we don't need to compress this spring down flat. It's just a little bit. Can you see how much motion it is? That's maximum motion. Probably doesn't always do that much motion. We have one other thing to notice. Right in the center of the diaphragm, there's a hole. And most of the time, this is pushed right in there and seals that hole off. If for some reason, and usually only when you're reducing the pressure, the pressure underneath is going to be higher, much higher than the force on the spring, and this will lift up even further than the maximum travel that this will go, and that will allow air to vent out through here, and it will come out through the top of the adjusting screw and vent the air off. And as you adjust a pressure regulator, if you reduce the pressure, you hear the hiss of the air being relieved downstream. Otherwise, if it didn't do that, we would have to cycle the cylinder downstream or open a valve to let the air out to reduce the pressure. This doesn't work as a safety relief valve, but it does relieve some excess pressure, usually, as I said, only when you're adjusting it. This piece slides in here, and if I get it in right, it engages with teeth in here, so as we turn this down, it pushes down, and then this part is sitting on top of the spring to compress the spring. So now I'm going to put it back together again. I'll drop the diaphragm in there, put the spring on, slide this back in. Wow, first time. Okay, I'll put the spring, that's the easier way to hold it. There we go. We'll thread this down nice and snug. He said as if he could do that. There we go. And since we're not going to use this, I'm not going to put it down super tight because we have to be able to take it apart again. I put the piston back in, or my poppet back in, and I put the bottom cover on. There are times when a regulator will, it'll constantly be hissing. You might adjust a little bit and it'll stop. I find that what you usually have to do then is take the bottom off, take the poppet out, and clean the seat and clean the poppet itself, and then you should be able to keep going. It should be done on a regular basis, cleaning the regulators. I'll try to slide this, slide it on the right way. Said as if it would go on the right way. There we go. And back together again, pretty much ready for service. Here is our lubricator. This is the last element of the FRL. It's at this point we've got air is nice and clean, is at the proper pressure. Sometimes we put some lubricating oil into the airstream so that our components downstream, like valves and cylinders, are lubricated internally without somebody having to go and squirt oil into into them. The oil is contained in this bowl. We usually only want it to be full, no fuller than this, and of course it can't get any lower than the bottom of this tube, because this tube is how the oil gets up into the stream. We're going to take this one apart, which will take a few minutes. We will pause while I get one of these plastic covers. This plastic cover just makes it look nice, hides all the rough metal in here, but away we go, we'll keep going. This is the filling hole. If I take this screw off, I can pour oil in through there. It would be sitting upright like this. You can pour oil in there without having to take the cover off. Just goes straight down into the bowl. With this element, this type of regulator, we have to turn the air pressure off before we take that off, otherwise the air will be blowing out. There's other styles where you can fill under pressure, but this isn't one of them. Okay, I'm going to take this off the top. You can see in here, this is where, this is probably just a little seal. It is so. There's an opening right here. This connects to this tube that's down into the oil. So when air is coming in from the inlet, some of the air acts on the surface of the oil, pushing down on the oil with the full pressure. Down in here, there's a hole here, the red piece down in here comes into the center, and it's really easier to see on this side. This is my venturi. So airflow going through the venturi has to speed up much faster than air that's going around it. So when the air speeds up, the pressure drops. So the venturi, the end of the venturi is on this little red plastic piece here, and we're just going to drop all that out so we can have a look at what's going in there. But first we'll talk about what's going on up here. So oil, because of the low pressure at the end of that red tube there, oil is sucked up, or actually pushed up from the air pressure, or system air pressure, pushed up this tube, comes up, get this apart, come out, wherever you are. Tiny pieces. And because I'm wearing my COVID-19 gloves, there we go, got it out. Cool. That's a screen so that the oil that gets up to the top here, I guess we don't get any dirt up here. I can adjust the screw here if I had the right size tool, Allen key. I can control the drops. You can see how, hopefully, you can see how, if I get this out, there's the hole, the oil will come down, and we will be able to see the drops coming down through this sight glass here. And we can adjust by turning this screw, we can adjust how fast the oil comes through, and it drops down back into here, where it keeps going down and brought into the airstream. And now we're going to take apart what's inside here. Okay, so here I am removing these two screws that are hopefully holding this whole mechanism in here. Don't lose the screws. Okay. That's inside there. This is our mechanism with the venturi in the center. If there's larger airflow, here's the other pointer. This plastic piece can deform, just like flaps that will open and close to maintain a specific flow through the center, through my venturi in the center, so that my pressure differential is going to be the same over a wider flow area. Now, what makes this a micro fog lubricator is in here where the drop comes down, it doesn't just go straight into the airstream there. It goes down below a little bit further. And as I take this out, the larger drops will fall back down into the oil stream, and only the smallest drops get carried in the air. Smaller drops will carry further through the system than pretty much all there is to a lubricator. Lots of little parts, but nothing moving. There's no moving parts in this one, so if we manage to get it together without losing any more parts, I'll be happy. The drops of oil come down here, and the bigger ones will keep going through. The smaller ones come back up around the side here, very fine mist, and gets carried off in the airstream out into the system. Now I'm going to try to put this back together again. He said as if he knew what he was doing. Slide that in. Get everything's lined up. Pick this screw up and drop it in place. There we go. Tighten that down again. Tighten those two screws. This is back together. I bet that would have pulled out, but I'm not going to try to do that because I would have to get it back in again. Now I need to get the top back together, so first off we'll drop in this little cover here and try not to drop that in. This one's on there. Get all these pieces, put that in there, and tighten that down. There we go. That's better. I'll put this filling cap back in. And we're pretty much back together. That's back in place. And we have a lubricator back together, ready to go to work for us again. So this is called a micro mist or micro fog lubricator. Only the smallest drops get through. This one is called an oil fog lubricator, and this one has a metal bowl, maximum oil level there, and if you get down here you have to refill again, and it shows just sight gauge to show where the oil is because you can't see through the metal bowl. The inside of this one is a little simpler than the other one, so I'm not going to bother to take it all apart. Side here, you can see here clearly inside there where the venturi is, the small hole, and that probably goes straight through. It does. I can get just right where I can see straight through, but it's a small hole. We still have with this one, we have the flaps that will open to allow excess airflow going through. So on this one, we have this red tube sticking down that is for the drops of oil to come back, so the bigger drops will fall into the back into the bowl, and only smaller drops get through. This one, all of the drops will go into the outlet, so you have to be very close with these, within 10 feet of where you're using the air. Otherwise, the bigger drops will settle out into the pipe and fill up the pipe or tubing or whatever your air is passing through, fill it up with oil and just cause you problems all over the place. Let me put this back together and we're done with lubricators. So this is our FRL system, all 3 units. A lot of factories now are using equipment that doesn't need to have the lubricator, so quite often you won't have a lubricator in modern systems or only in certain specified areas. So often you just need a filter and regulator. In fact, that's so common that they make a combination unit that is a filter regulator in one unit. And it's just, this basically is on the top and this is on the bottom. And we're not going to take it apart because I haven't looked in the inside of this one yet, so I want to keep it nice and pristine for us to look at. Okay, this is a complete system with sold as one unit with the filter, regulator, lubricator with a shutoff valve, so we can shut the whole system off in one place. This would be found on very close to any machinery that you are operating, and you can open it and air will pass through, shut it off, and the air will be shut off and will exhaust the pressure downstream. So here's our very own system for one side of the lab here. We've got our shutoff is up here. We've seen that in a previous lab. I have here the filter, the regulator, and the lubricator, and off into our system. This is a different manufacturer's system, but it works pretty much the same. And now we are done with the experiment for